Good afternoon, everyone. Once again, welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today I want to introduce a new topic in Pure Mathematics 4. And today we'll be looking at binomial expansion. And we'll be looking at expanding 1 plus x raised to power n. And one thing I would want to remind you is that binomial word is not new to anyone, because we were talking about Pascal's triangle in Pure Mathematics 2. And today I just want to explain what are the steps to expand a plus b raised to power n. And that is it. And this formula, the first term a is raised to the maximum index n. Of course, we expect b to be here, but raised to power 0, because anything raised to power 0 is 1. N1, this is how we get the coefficient of that particular term. We'll be using the calculator to get the coefficient, but you know the Pascal's triangle gives us the coefficient, but this bracketed part here, depending on the value of n, we keep getting coefficients of each and every term. But look, the power of the first term, a, becomes now n minus 1. If you're keen, you realize that n, if we were having n to start with, and then the second term, a, was raised to power n minus 1, the power reduced by 1. And b, which is the second term, was raised to power 0, and now is raised to power 1. And the next term, still coefficient here, we will see how we can get the coefficient from the calculator. A raised to power n minus 2 now, but now b raised to power 2. One thing I would want us to note is that what I have circled here in red is the entire sum of the indices. In each and every term, the sum of indices is n. So, and you can see the first term, the index is n minus 1, n minus 2, until we get to a raised to power 0, the very last term. So the index of the first term start from the highest and keep reducing until we get to 0. And the index of the second term starts from 0 and keeps increasing until we get to the maximum. One thing I want you to note that is the sum is always n, depending on what n is. So if n was 10, 10 plus 0 is 10, 9 plus 1 is 10, 8 plus 2 is 10, and 0 plus 10 will maintain 10. And this approach will always give you n plus 1 terms. That means if our index was n, then we have n plus 1 terms. For example, if our index was 2 or 3 for that matter, then our number of terms will be 3 plus 1 will be having 4 terms. So this formula produces finite number of terms that you can talk about, a number of terms that you can actually count. They only need to be one more than what our index was. But when n is a fraction or negative number, then a different formula is used, which gives us an infinite series. When n is a fraction or a negative number, assuming we are having 1 plus x raised to power n, and n is a negative or a fraction number, the terms we expect to have 1, that's always the first term, plus nx, plus n multiplied by n minus 1, then x squared, this is x raised to power 1, this is x squared, this is x raised to power 3. 1 times n, x. The third term n minus 1, x squared over 2 factorial. The second term is n times n minus 1 times n minus 2 multiplied by now an increased index of x, which is power 3, everything over 3 factorial, all the way until the very last term. We may not really have the last term, but let's talk about n minus 1, n minus 2, all the way as we keep reducing the number of n minus r plus 1 multiplied by x raised to power r over r factorial. And it is this part I want to explain using what we have. So if you talk about this, just this part, and I'm going to use this term, we are having n minus 1, n minus 2, and then multiplied by x raised to power 3. So you can already see this 2 is 1 less than this 3. So what are we saying? If we were having r to be equals to 3, so we're going to have n minus 1, n minus 2, n minus 3 plus 1. This is r plus 1. Then x raised to power r, everything over r factorial. So that's how we come up with this. We'll see it clearly in an example. So the whole of this is going to be n minus 3 plus 1, this part, n minus 3 plus 1. What is 3? Our index of x, plus 1 is a constant, such that we're going to have 3 factorial here. So the same understanding is brought in the very last, as we approach the last terms, n minus r plus 1, x raised to power r over r factorial. If you talk about the last term here, n minus 2, 2 is 1 less than 3 is 3, and of course under 3 factorial. So the same thing comes over here. And I want us to just look at example 1. Just look at example 1 using the same. It might be confusing for now, but as we move forward, there is nothing to worry about. Just make sure that you follow closely. The expansion is valid when the modulus of x is less than 1 and n itself is a real number. And we have infinite number of terms. Why do we have infinite number of terms? Because there is no way this will be 0. It's a fraction or negative number. There is no way this can be 0. There is no way this can be 0. There is no way this can be 0. And there is no way this can be 0. And if it's not 0, then we can move on and on and on and on. Because when it is 0, then multiply by 0 multiplied by anything, it will be 0, and the whole thing ends there. Find the first four terms in the find the first four terms in the expansion 1 over 1 plus x, and in this case we just have to write it in index form because we are expanding a binomial. The moment we are told to find the first four terms, you know that is expansion, binomial expansion, and we just write it this way according to the laws of indices, and n is -1. This is not positive, it's a negative number, so we expect infinite number of terms. According to this formula, you see now with this one, we cannot use this because our n is -1. We can only use this one because n is -1. So 1 plus x raised to power -1 is given by 1 itself, of course, because of this, plus what is n? Our n by itself is -1. So -1 times x, -1x, this is nx, plus n, which is -1, n minus 1, -1, because we are told n multiplied by n minus 1. This is our n multiplied by n minus 1. So -1 minus 1 is -2. Multiplied by x squared, here we had x raised to power 1, everything over 2 factorial, plus n minus 1, n minus 2, multiplied by the next index of x power 3, all over 3 factorial. And we have a lot of business here to clean up this one, and we are going to have something like this. 1, of course, -1 times x is -x. -1 times -2 is 2, x squared over 2 times 1. Remember, every time we talk about 2 factorial, This means 2 times 1. 3 factorial, this means 3 times 2 times 1. That one should be known. And n factorial, it's n times n minus 1, n minus 2, n minus 3, all the way, reducing to 1. So, positive 2 over 2, we get 1. Minus 1 times minus 2 times minus 3 is a minus 6. Minus 6 all over 3 times 2 times 1 because of 3 factorial. This is a negative 1. And you can talk about multiply by x cubed. So the entire kind of presentation gives us now 1, it gives us 1 minus x plus x squared minus x cubed plus all the way. You can go to wherever you want to go, but because the question asked us to give the first 4 terms, yes, there you are. This is just the beginning. Don't worry, you will get it, but from the scratch, get used how to use this formula. I'll be explaining it further in the following examples. For now, this is it as far as example 1 is concerned. Please follow, subscribe, and of course, share widely. All right?